We'll be spending more time on set and set notation a little later on in this chapter. Today we're going to start our lessons on compound inequalities. Compound inequalities consist of two distinct inequalities, two simple inequalities that either are joined by the word and or the word or. So there are two types. There's the and or the word or. You find the solutions of compound inequality either by identifying where the solution sets of these distinct inequalities overlap, or by combining the solution sets to form a larger solution set. The graph of a compound inequality with the word and contains the overlap of the graphs of two inequalities. It would be x is greater than 2, so again, x is greater than 2, so I have an open circle, and x is less than or equal to, closed circle, at 4, shading in between. This is the overlapping of these two inequalities, and it has these boundaries. It can only go between 2 and 4, and the fact that it doesn't contain 2, but it does contain 4. This can also be written as x is less than or equal to 4 and x is greater than 2. Okay, so we're going to be looking at it as two separate or one compound inequality. The graph of a compound inequality with the word or contains each graph of two inequalities that form the compound inequality. So there's going to be two separate ones, and we're going to see that these go in opposite directions. We find a circle at -2, open circle, and everything less than shades to the left. Or the solutions could be x is greater than or equal to 1. So here we've extended this solution in two directions. The word or says it's this or that. I always think of the word or as the or on the boats, and the or on the boats go on opposite sides and of the boat, one on each side, and on this we have a shading, one on either side, to the left and to the right. So let's talk about solving them. You can write the compound inequality as the compound and inequalities as two separate inequalities, or you may also solve it by working all three parts at the same time. Here is my compound inequality. -3 is less than or equal to m minus 4, which is less than 1. Now, by working all three parts, I see I have something on the left, an inequality, something in the middle, that's the second part, the inequality, and something to the right, the third part. If I want to work it all at the same time, which is the method I prefer, I start isolating my variable using my inverse operations, and I'm going to add 4. Not only to the center to isolate m, but to the right and to the left. When I look at this now, I have 1 is less than or equal to m, which is less than 3. And this could be rewritten as, or read actually, as m is greater than or equal to 1 and m is less than 3. And if we do a quick number line, we know that there are boundaries at 1 and 3. This first part, if I want to take it apart, says m is greater than or equal to 1 and m is less than 3. Ands get joined in the middle. Here's what I meant by taking it apart as two separate. If I sort of forget about the less than -1 for a moment, I can write -3 is less than or equal to m minus 4, and I could add 4 to both sides, and I get the statement that m is greater than or equal to 1. I could also take the second half, forgetting about the -3, and solving m minus 4 is less than -1. Adding 4 to both sides, I get m is less than 3. So I get the same answer. I just think that it's, I don't know, to me it's a little more convenient just to leave it as one inequality. Let's try an additional problem. What if we had, and again, let's take one that I know will work. I don't want to give you something, especially as we're starting out, that doesn't. Let's take a look at an and that has the following statement. Okay. Again, I see that I have two inequality symbols and an expression in the middle. My goal is to isolate x. If you like working at it as working all three parts at once, you'll see that we have to subtract 3 on all parts. -7 is less than or equal to x. I've isolated x, which is less than or equal to 5. Again, I would set up my number line. I have closed circles at these boundary points or these parameters here, and it says that x is greater than or equal to -7 and x is less than or equal to 5. Ends join in the center. So there's a couple of examples of our and inequality. Let's take a brief look at the ors. The ors, again, I think of the oars on a boat that go in opposite directions, and we're going to look at a possibility. You'll always see the word or. So if I'm going to be solving compound inequalities with the word or, you will definitely, you won't necessarily, sometimes you might, but you won't see the word and often, but you will always see the word or. So this next couple will be involving the word or. What are the solutions to an inequality of 3x plus 2 is less than -7 or -4x plus 5 is less than 1? We solve these separately. And graph it on the same number line. So go ahead and start solving. We start off these as 2 steps, so we'll subtract. We get 3x is less than -9, so x is less than -3. Or, I have to put that word or in my solution. I'll subtract 5. I get -4x is less than -4. Divide by -4. I get x is greater than 1. Reversed my inequality symbol because I divided by a negative. I need something at -3 and something at 1. Let's graph the first part of this. First part says x is less than -3, open circle and shading, or x is greater than 1, open circle and shading. So now you have a couple of examples of a compound inequality, the ands and the ors, and once again, when we meet up, we'll do more examples.